welcome back.
Yeah, man, how you doing? You know you like that.
What's up, y'all? Welcome back to another episode of Math Talk with Mr. Faison, and I'm Mr. Faison, or Mr. Faison. As long as you know, today we're working on combining like terms. Let's jump into it. There we go. Combining the like terms. So now what we're looking at is I put 3 problems on the board for us to run through together so we can see what it's like to combine like terms. So let's take a look at it. The first one we're talking about 3b plus b, right? Well, I need y'all to understand when we combine like terms, we need the variable and the exponent to be identical twins. Now, if we look at this first one, I noticed that it just says b, right? And this has b, so we know that these are like terms because the variables are the same. We don't see an exponent, but I need you to understand, right here, where exponent would be, it's just understood that it's a 1 right here. All right? Just like right here. It's not an exponent right there, but it's understood since there's not an exponent that it's just going to be a 1. All right? Also, what I need you to know is, in front of this b, there is an imaginary number that we can't see. That imaginary number is a 1, right? So the coefficient of this variable right here is a 1. So if you don't see a number in front of a letter, just understand that it is a 1. Right? So what I'm going to do is, all I do is add the coefficients, right? On like terms. If the terms are alike, I just add the coefficients. So with this one right here, what I'm looking at is, this is going to be 4b, okay? So I don't change the variables or the exponents, I just add the coefficients, okay? So I just add the big numbers. Now if I look down here at problem number 2, I have x squared minus 3x squared plus 7, okay? So if I look, the ones that have like terms are x squared and x squared. Now I just told you, in front of this x, we can't see it, but there is a 1 in front of it. So we understand that it's a 1 in front of this x squared. So what I'll be doing is a positive 1 minus 3, all right? Now, if you don't remember how to add and subtract positive and negative numbers, tap back into one of my old videos because you know it's there, all right? But what we're looking at is 1 minus 3 is going to be negative 2. And we just keep the x squared. Now, since this 7 has no other like terms, we're just going to bring the 7 down. Okay? So I want you to know your answer can never be 7 minus 2x squared. It would always be negative 2x squared plus 7, right? Your 7 couldn't go in front, right? The number with the highest exponent is going to go first, all right? And the number that has a variable is going to go first. Let's jump into problem 3 so I give you a better example of what I mean. So let's look at problem number 3. What we're looking at here is 6x minus 3x squared plus 5 minus 2x squared minus 10x, right? We want to go with the one that has the highest exponent first. That's the one we're going to start combining first. So if I look, I have an x, but I also have an x squared. So I'm going to go here first. And I see another x squared right here, negative 2x squared. So I'm going to combine negative 3x squared and negative 2x squared. That's going to give me negative 5x squared. Remember, if they have like terms, I just add or subtract the coefficients, which are the big numbers. Now, I can mark that out. I'm not going to need that anymore. Now I see my x. My x is going to be the next one, right? Now if I'm looking, I have 6x minus 10x. 6 minus 10 is going to give me a negative 4. Negative 4x. Now I can mark that out. I can mark that out. This 5 doesn't have any like terms, so I'm just going to bring the 5 down. Plus 5. That'll be my answer, okay? Just like this was my answer. Hey, y'all. That's another episode of Math Talk with Mr. Faison, and we just knocked out combined like terms. Hopefully, y'all took a screenshot, y'all wrote it down, did whatever y'all had to do to make sure y'all got it. And, you know, I'm going to catch y'all on the next episode, all right?
God's plan, God's plan.